Hi everyone, welcome back from the spring break. So today is March 20. We'll talk about section 1.8. Alright, so I gave you 1.8 last time before the break, but I do have some extra here if you need it. And this week, you do not have any homework or new quizzes, but I hope if you miss some serious homework or if you miss exam correction and wrapper or practice exam 1, I send you an email, right? You receive my email, so please submit those pieces of work as soon as possible. Okay, everybody? And when is our exam 3? It is on March 7th.
Exam 2?
Sorry, exam 2. Yeah. Yeah. Right, exam 2. it will cover chapter 2 and 3 and section 1.8. And yeah, so today we'll talk about section 1.8. All right, so let's look at our quiz. So this is your quiz. Do you remember that, everybody? So, okay, what are the 4 transformations? What's the first one? Move your hands. And left is what? Plus or minus? Plus.
Oh,
right is minus.
Okay,
yeah,
yeah,
shift left or right. Yeah, yes. The second one.
Change over the x-axis.
X-axis? Y-axis. Reflection over the y-axis. The third one.
Reflection.
Yeah, x-axis. And what? Vertical stretch. And then the fourth one. Up and down, up and down. Okay, so do some math exercise. How about the graph? The basic graph. Line. Everybody move your hands. Line. Move your hands. X squared. Like you. Like I love you. You. Okay? And then X cubed. Yeah. Like one hand up, one hand down, right? And square roots. Yeah, only one side. Okay, square root of x. X must be greater or equal to 0. Keywords. Like that, right? And x to the value of x. We shape, okay? And not only the shape, we also need to focus on the key points. Remember those key points? It has, like x squared, it has through 0, 0, 1, 1. 2 square is 4. And then minus 1, 1, minus 2, 4. Right? So remember those key points. So this is your quiz. Okay? I asked you like x squared on the quiz. So on your exam, I might ask you x squared, x cubed, square root of x, cube root of x, or absolute value of x. Okay, everybody? So be prepared for all 5 of them. Okay. So this is the parent function, x squared. It has 5 key points. Make sure you pass through those 5 key points. And then look at this. Do we have shift left or right? Follow the order. Yeah, x minus 3. So minus is right. So shift right 3 units. All of those 5 key points. Shift to the right 3 units. And then do we have minus sign in front of x? We don't have it in front of x. The minus sign is in front of everything. Right, everybody? If the minus sign is just in front of the x, then this is reflection over the y-axis. But if the negative sign is in front of everything, then this is reflection over the x-axis. Therefore, reflect about the x-axis. So flip it down. It means same x, but the y, put a minus sign in front of the y. So this point, 3, 0 stays here, but 4, 1 becomes 4, negative 1. Right, anybody? And then, okay, next. Do we have stretch? See, multiply by 4. So stretch by a factor of 4. Okay, so stretch by a factor of 4. Let me make sure. Okay, the microphone is working. All right. Okay, and then keep going. Last one, act 2. So shift up 2 units. Oh, sorry, by the way, stretch by a factor of 4. You look at those key points. So this point, it was 4, 1. Stretch by a factor of 4 means your x remain the same, but your y value multiplied by 4. So therefore, the -1 multiplied by 4 becomes -4. Okay? And then if you want to draw more points, this point, it is 5, -4. The -4 times 4 is -16. It would be so negative. It would be, yeah, outside of this region. Okay, everybody? So at this picture, you just need to draw 3 key points instead of 5 key points. Okay? And then here at 2, move up 2 units. So all those 3 points shift up 2 units. Any questions about the quiz? Good? All right. So let's look at our mistakes. Okay. So sometimes, even though you might know the answer, but how detailed I want you to present your work is also very important because you want to get all the possible points. Right, everybody? So let's look at our mistake carefully. So here, the key points. So here, this was -1. -1 times 4 is -4. So not -8. So for the important points, please label. Okay? So the important point, like 1, 1, 2, 4, please label the important points. Okay. And then for here, what is this? Okay, so this is -4, and we go up 2 units. This should be -2. So for the important point, label so I know what it is. Is that clear, everybody? Label the important points. And then here, let's see. Okay, left plus, right minus. Okay, so left plus, right minus. So this shift to the right. And then with fraction, see, with fraction, this is over the x-axis, not the y-axis. This is the x-axis. You can see this is like the mirror image across the x-axis. And then here, when you stretch, the x-coordinate remain the same. Y-coordinates multiplied by 4. So that's why here, -1 multiplied by 4 is -4. And then here, -3 is 0. 0 multiplied by 4 is still 0. And then -1 multiplied by 4 is -4. Okay. So yes, be careful and shift up. So in exam 2, you will have a problem like this. It might not be x squared, it might be x cubed, or square root of x, or cube root of x, or absolute of x. But the step is similar, okay? Each picture is like 2 points. But for each step, you have the formula, you have the transformation, and you have the graph. If you have a mistake, then you will get 1 point off. Okay, this is how I grade this problem. Okay. So keep going. Here, what are the key points? You know the shape, but please label the key points. So here, the key point is 0, 0, 1, 1, and 2, 4. So label the key points. Because otherwise I cannot quite tell what you're shooting. See, it looks like this is too far, it's like 2. But no, it's actually shift to the 3, okay? And write down the formula. Formula is an equation, so don't forget the y. And this is reflection, but reflection and stretch, we separate into 2 steps, okay? So even though they're both in like the step 3, but when you draw the picture, please separate them into 2 pictures. Is that clear, everybody? Yes? If you can hear me, raise your hand. Okay, good. And yes, and then shift up, right? And then what is the formula? So every step you need to include the picture, the formula, and the transformation. Okay, so that is the requirement. Okay, and so this is the attendance sheet, and also this is my available hours this week. So if your score is lower than 70 in your exam 1, please write down your name and write down what time you will meet. I really, really want to help you. Okay, so let's hold our hands and try our best to improve. Okay. All right, continue. So then this one, yeah, shift right 3 units. And please follow the order, okay? So shift up and down is the last step. Because if you change the order, your answer won't be correct. We have to keep that order. Because if you change the order, your translation might change. Instead of shift up, maybe you shift down, okay? So be careful. Yeah, so please follow the order. Otherwise, the translation will be wrong. Okay, and then, yes, key points. Label the key points. Even though you know the shape, that's not enough. Remember the key points. Everybody clear? Everybody? Yeah? Write that, draw the key points. Okay. And then, oh, that's it. Any questions about the quiz? No? All good? All right. So last time we did 3.2, right? So let's have a little review about 3.2. So 3.2, we talk about how to graph polynomial, right? And here are the steps. Remember I taught you 2 methods? Method 1 is the test point method. First step, factor the polynomial completely. So we want to factor, okay? Because after we can factor, we can set it equal to 0 and find the roots. The roots are the x values such that the y is 0. It's like the x intercept. Okay? So you factor it, and then you set each factor equal to 0. You can solve for x. That will give us the x intercept. Okay? And then to find the y intercept, you evaluate f of 0. So you plug in x is 0 and you find the y. Right, everybody? Because the y-axis corresponds to x equal to 0. So that's why you set x is 0 and you solve for y. In this picture is the same point. The x-intercept and y-intercept is the same. Okay? And then plug those points on the xy plane. The test point method, you look at the real number line, it's separated by those 3 intercepts. So we have 4 pieces. On each piece, you pick a test point and then plug into the factor form. Okay? Plug into the factor form and then to see whether it's positive or negative. If it's positive, then the graph lies above the x-axis. If f is negative, then the graph lies below the x-axis. This is method 1. Okay? But usually I don't recommend doing method 1. The test point is good when your problem is simple. But when your problem is complicated, then don't use method 1. Use method 2, okay? The first step is similar. You also factor it. Okay. Common mistake. When students see this problem, instead of factoring, they multiply out. Do not multiply out. We want factor. Everybody say factor. Factor. Factored. Okay. That is the first step. If it's already factored, perfect. Then set each factor equal to 0. Okay? So set this factor equal to 0, we get x is 1/3. Set this factor equal to 0, we get x is -7.
How'd you get x plus 7 cubed again?
Oh, I changed the problem. Remember I said, oh, the problem is so easy. Let's make it harder.
Oh, okay.
Yeah. Okay. Because we said we cover the examples slower, so we cover harder examples and less examples. Okay? Yeah. Alright, so those are the x-intercept, and remember x-intercept and y-intercept, they are points. You give me the order there. Right, everybody? order pair. And then the y-intercept, you plug in f of 0. So you get negative 1,715. And it's a very negative number. It's okay. On the xy plane, just plug the key point. Don't put so many bars. You're not going to put 1,700 bars there, right? You won't. So just put one point and say that's negative 1715. Okay? Make it clean. Don't put a lot of bars. Just put those key points, label them. Okay? And then, okay, so we look at the leading coefficients. What's the leading coefficient? If you have the factor form, you collect the leading coefficient from each factor. So here, this factor is negative 5. And then here, what's the leading coefficient of this factor? 3. But you have a square. So include the square. Right, everybody? And then next factor, the leading coefficient is 1. 1 cubed. So this is the leading coefficient. And we just care whether it's positive or negative. And if it's negative, then we start with the right lower corner. You remember that, everybody? Okay, so start with the right lower corner. And then, so that's why you draw here, and then, oh, let me open my camera so my online student can see me. So hopefully they can see me now. Okay, so we start with the right upper corner, and then we connect this point 1/3 0. And then you look at the multiplicity. So 1/3 corresponds to which factor? The 3x minus 1, right? And the multiplicity is 2, so it's even. Even then we bounce off, right? So it bounce off. And you connect this point, so connecting point gain. And then you connect this point, it corresponds to the factor x plus 7. And cube is out. So we cross. Okay, everybody? And this is good. Yes. So this method is good in general, especially when your problem is more complicated. Okay, everybody? So keep this in mind. And so last time we talked about session 1.8. We did example 1, right? Greater than 0. Greater than 0 means it's a portion of the graph where it is above the x-axis, right? So let's say, oh, greater than 0, this part. So therefore, what are the x values? You kind of imagine there is a sun, and you put it down. What is the shadow? The shadow is right here, from negative infinity up to 2, but you don't include the endpoint, because you're talking about y is positive. So it's above the x-axis. We don't include the endpoint. Do you remember that, everybody? Yes. Greater than 0 is above the x-axis. Less than 0 is below the x-axis, right? And then last time we did example 2. And now let's look at example 3. Okay, so this is the graph of this polynomial. So part A, we're talking about, this is the y. Y is negative, less than 0. Less than 0, which part is less than 0? Less than 0. This piece and this piece. Right? Do we include the 0? Do we include the endpoints? No, less than 0. So below the x-axis. Okay, let's see. Less than 0. So let's use red color. So which is this piece, not including endpoint, and this piece, not including endpoints. And we want to find the x values. So imagine there is a sun, and what are the shadows? You see, the shadow is like that. Imagine this piece projects on the x-axis. Here are the shadows. So can you tell me what are the x values? Use interval notation. Negative infinity to -1, open or close? Open, yes. Minus infinity to -1, open. And union. What do you say? This one. 3 to infinity. Yes. Very good. Okay. So this is the y is negative, which is below the x-axis. Okay. How about y is positive? See here, y is positive. Then we have above the x-axis. This is tricky. Look at the graph. Above. So above, which means is on top of the x-axis. But do we include the origin? No. Right? No. So this is tricky. Above. So this piece, but here do not include the origin. And then keep going. Do not include the endpoint. So what are the x values? You always say from the negative numbers. So -1 to 0. And then union. Yeah, 0 to 3. Good. Right, everybody? Okay, how about part C? Now we allow it to be equal to 0. So we allow the endpoints, right? So which means it's similar to part A, but instead of parentheses, you put brackets. Exactly. Right. Okay, so minus infinity to -1 brackets union brackets 3 to infinity. Do I put brackets on the infinity? No, because we never reach infinity. We're approaching it, but never reach. Okay. How about part D? Greater or equal to 0. So, which means we now include those 3 points. Right? We include that n point. Then what do you say? It is from -1, open or close? Close to. Do we need to break into 2 intervals? No. See, it's connected now because we included 1, 0, 0. So we don't here. We have to break it into 2 intervals because we don't include the 0, 0. So it's broken into 2 pieces. But because now we include a 0, so you don't need to break it into 2 intervals. You just keep going from -1, go up to 3. Do you see that, everybody? Mm-hmm. Yes. So -1 brackets up to 3 brackets. So this is how to solve inequality graphically. If you have it, the graph, then y is positive, just look at the pieces above the x-axis, right? And y is negative, look at the pieces that's below the x-axis, and then find the shadow on the x-axis, find the x values. And using the interval notation. If you can understand this problem, please raise your hand. Okay, good. Let's keep going. Okay, now how do we solve polynomial inequalities? Here are the steps. Move all terms to the left-hand side of the inequality. We move all the terms to the left-hand side. And then factor the left-hand side completely. So key words of today, factor. Okay? Factor. You don't want to multiply everything out. The goal is to factor. Okay. And then, yes, the values where the left-hand side equals 0 are called the critical values of the inequality. Sketch a real number line and plot those critical values. And then the critical value splits the number line into several distinct intervals. Choose any point. Okay, so this is the test point method. You pick any point from each interval, and then you see whether the inequality is positive or negative. But we don't do that. We use method 2. Okay? So you look at the leading coefficient. If it's positive, you start with the right upper corner. If it's negative, you start with the right lower corner. And then you look at the multiplicity. If it's odd, you pause the x-axis. If it's even, you bounce off. Okay? So let's stick with method 2 from now on. Okay. Example 4. All right. So how do we factor? We might not have enough time. So for the easy example, I will let you to do at home. Is that okay, everybody? Yeah. So on the course website, I have solutions to this. So you work at home, and then after you finish, check your answers with the solution online. Okay? Okay, so do this one. Factor completely. So first step, move all the terms on the left-hand side to the right-hand side is 0. Is it? It's already 0 on the right-hand side. That's good. Step 2, factor. Do you see any common factor? X. So after you factor out x, what's left? I mean 2x squared minus 9x plus 4. Yes, good. Can we factor further? Can we factor further? Okay. Everybody, if you need more exercise of factoring, please come to see me. Okay. So also on the Mobius resources, in chapter 1.5, is about factoring. We have a lot of exercise factoring there. Okay, so how do we factor? What are the factors of 2x squared? Factors of 2x squared. 2x and x, very good. Factors of 4. It could be 1 and 4 or 2 and 2. 1 and 4, right. And which one? So x plus mean 4? Yes, very good, because it's negative, so we put minus. So you multiply the outsides. See, 2x times negative 4 is negative 8x. And then minus 1 times x is minus x. So you add them up together, you get negative 9x. Okay? So you might have different ways of factoring. Feel free to use it. Okay? All right, so have we factored completely? Questions? 8 and 1. Oh, this is 4. So it's either 1, 4 or 2, 2. We cannot get 8 and 1. Oh, yes. So 2x times negative 4, we get negative 8x. Yeah, because this is minus 9, so therefore we need negative. So if we put positive, we will get positive 9x instead of negative 9x. Therefore we need negative. Yeah. So that's why you might like change different combinations and see which one works. And you add them up. So multiply the outside and multiply the inside, add them up together to see if you get the middle. Okay? Alright. Good. So now we set each factor equal to 0. So x is 0. 2x minus 1 is 0. X minus 4 is 0. Okay, how about you take turns to answer my questions? Come on! 2x minus 1 is 0. What is x? Good. So we add 1 on both sides and divide it by 2, we get 1/2. Evan! X minus 4 is 0. What's x? Yes. Okay. So here we are solving inequality. We're not grabbing the polynomial. So you don't need to put x intercept and y intercept. Okay, everybody? So now you draw the real number line. And these are called critical values. Okay? Put those critical values on the real number line. And 0 is the smallest, 1/2 is bigger, and 4 is the biggest. Is that okay, everybody? So make sure the negative number is on the left hand side and the positive number is on the right. Okay, from smallest to biggest. Okay. And then what is the leading coefficient? Question. Do we look at the factor form or the original form? Original form, right? If we have an original form, look at what is the leading coefficient? 2. See? Leading coefficient is 2. Do you see 2 is positive? So you start from the right, upper or lower? Upper. Positive, upper. Okay. So if leading coefficient is positive, start with the right upper corner. So when you take notes, okay. So when you take notes, please write down the steps. Just remember my weekly checklist and take notes in class. If you don't have enough time to finish all the notes in class, I hope after class you can look at the lecture videos to write down your notes, okay? And then tie the solutions. Redo the problem. See if you can do it. Okay, so that is how you make sure you understand every problem from the in-class notes and also from your homework, quiz, and practice exams. So you hide the solution to see if you can redo the problems. Okay. All right, so start with the right upper corner. Okay, so when you reach the 4, okay, first of all, you look at, do we put open circle or solid circle? Look at it, greater or equal? Solid circle. So if you see greater or equal or less than equal, you put solid circle. If you see greater than or less than, put open circle. So in this case, we put solid circle. Okay. And then when you reach the 4, you look at the factor, what? X minus 4. What's the multiplicity? We ask, Cora, what's the multiplicity? The root is -4. The multiplicity, the root is 4. The multiplicity is the exponent of this factor. 1. 1 is odd or even? Odd. So we bounce off or we cross? Do we bounce off or cross? Cross. See? Okay. Yes. So if you forget that, make sure. Okay, after class, write it down. This is on our notes 3.2. Okay, so review your notes. Okay. And then we go to 1/2. Let's see, let's do this. Jackson, 1/2. What's the multiplicity? So what is multiplicity? So 1/2 corresponds to the factor. The corresponds to the factor 2x minus 1, right? Look at this factor. What's the multiplicity? Multiplicity is the power, the exponent of this factor, which is 9 is up there. So this is the factor. This factor to the power of, if you don't see any power, then we know the power is 1. 1 is odd or even? Ah. Then we cross or we bounce off? Cross, yes. Okay. Zach, 0. What's the multiplicity? 1. Yes. Multiplicity is the power. Okay. And these numbers that are the roots or the 0 of the function. Multiplicity is the power of the factor. 1 out even. Cross the bounds. Cross, yes. Okay, and we are looking for greater or equal to 0. Greater is above the line or below the line. Above or below? Greater than 0? What is it? Okay. So we're looking for greater or equal to 0. Greater is above or below the line. Is it above the line or below the line? Above it. Yeah. So above it, which is these. Therefore, interval notation. Haley, what do you say? Parentheses or brackets? Brackets. And then 0. And then 1/2 parentheses or brackets. Brackets. And then union parentheses or brackets. Brackets. And then 4 to infinity. Yeah, and then parentheses. Yes. So this is how we solve the inequality.
Use 0 to negative infinity?
No, because it's negative. We're looking for greater or equal to 0. So above the line. It's only the positive or equal to 0. Okay. Any questions about example 5? Are we all good? Okay.
Sorry.
Sure.
So you said it. The multiplicity is 1 you got.
Yes.
What do you got?
Even. It's square. Then you bounce off. Very good. Okay. So we keep going. Okay. So what happens if we have let's see, radical expression? Okay. So if we have not radical, rational expression. So the critical values will now be the values that make the numerator or the denominator equal to 0. But keep in mind, your denominator cannot be 0. The numerator can be 0. So therefore, if you see greater than or equal, then for the numerator, you put solid circle. Therefore, your denominator is always open circle. Okay, right, everybody? So let's see. Let's do. Okay, let me see which problem is better. Okay, let's do this problem because we don't have enough time, so we cover less problems. So let's see how many we can cover. Let's look at this one. Okay. So the first thing we check. All terms on the left hand side, so your right hand side is 0. Your right hand side is 0, right? And have we factored the left hand side completely? Right? It's already factored completely because now each factor is a linear factor, right? And then raised to the corresponding power. So all terms on the left hand side check, factors check. Okay? Then we're ready to set each factor equal to 0 to find the critical number. Okay? The common mistake is students get lost. They try to multiply out. No, our goal is not to multiply out. Our goal is to factor. And it's already factored. Okay, everybody? So don't go back to the process. So our goal is to factor. It's already factored. So now set each factor equal to 0. So we get 2x minus 7 is 0. And then what's the next factor? 3x plus 1 is 0. What's the next factor? X minus 7 is 0. What's the next factor? 4x plus 5 is 0. right, everybody? So for x, Alice, what is x? 7/2, good. Peter, what's x? Yeah, good. Even, right? What's x? Yes. Chan, what's x? Chan. Chan. Yeah, very good. So these are called critical values. All right. So here is greater or equal. So you want to put solid circle, right? But for the numerator, it could be 0, so you put solid circle. But for the denominator, can your denominator be 0? No. So for your denominator, we put open circle. Okay, so here you want to, for the numerator zeros, we put solid circle. And for the denominator 0, or roots, okay, if you don't like the name, you can call it roots. You put open circle. So therefore, the real number line. And which number is the smallest? Yeah, which number is the smallest? Yeah, -5/4. The next one? -1/3. Next one? 7/2. Next one? 7. And your numerator is the 7/2 and -1/3, right? So you put a solid circle on 7/2 and 1/3. See, they are solid circle. And then for your denominator, which is 7 and -5/4, we put open circle. Is that clear, everybody? Because your denominator cannot be 0. So from we call the last problem. If your inequality includes 0, it's greater or equal or less than 0, then you want to put solid circle. If it does not include 0, greater than or less than, you put open circle. So if it's greater than or less than, you put open circle for other groups. But now you have rational expression. You want to put solid circle, but the denominator cannot be 0. So that's why for the denominator roots, you put open circle. For your numerator roots, you put solid circle. Okay, now what is the leading coefficient? You look at the leading coefficient from each factor. Erica, what's the leading coefficient of this factor? 2. So we put 2 square, right? And then what's the leading coefficient of this factor? 3. Yeah. So we put 3. What's the leading coefficient of this factor?
X.
Yeah, 1. So 1 square. And what's the leading coefficient of this factor? 4. So 4 cube. Okay, and you don't need your calculator because we just want to know whether this is positive or negative. And it is positive or negative. You see all the factors are positive, so positive, yes. Then do we start with the right upper corner or lower corner? right upper, right? Upper. Okay. Colon again. When we meet 7, what is the multiplicity of 7? So 7 is x minus 7. What's the multiplicity? 2. Yes. 2 is out even. Even. So we cross or bounce up? Bounce. Exactly. Bounce. So we go back. Yes. 7. 7 half. 7 half is what's the multiplicity? Cross. Okay. 7 half is here. It corresponds to the factor 2x minus 7.
Oh.
Yeah. Do you see everybody? The multiplicity is 2 evenly balanced. Okay. Kara, negative 1/3. What's the multiplicity? 1. Out even. What do we do? Cross. Yes, cross. Oops. I don't want to erase it. Okay. Where is it? Eh? Something. What's wrong? That's weird. Okay, so we said we cross, right? Something wrong with maybe I need to save it first. Oh, okay. All right, cross. It does not allow me to draw on it. Okay. Jackson, negative 5/4. What's the multiplicity? Yes, this corresponds to the factor 4x plus 5. And you see, 3 is up, so we cross or bounce up. Cross, yes. Okay, good. So we have plus, minus, plus, plus, plus. We are looking for what? Greater or equal to 0, right? So that means in all the above the line. Okay. Interval notation. Zach, what do you say? Interval notation. Negative infinity to negative 5/4. Parentheses or brackets? Brackets? Parentheses. The open circle. Parentheses. Union what? Parentheses or brackets? Parentheses? Brackets. And then what do you do? See here, we go. Do we need to break it into 2 intervals here? No, because it's solid. We include points. We go. Do we need to break it? Yes. So it's 7. What? Parentheses or brackets? Parentheses, yes. Union 7 to positive infinity. Yes. Right. So your exam 2, you will have a problem like this. Okay, everyone? So our goal. What's the key word? Start with the F. Factor. Don't multiply out. Factor. Set each factor equal to 0. Yes. Because you it's greater or equal to 0. So you can include is this how you want to exclude it? That's what the Oh, sure. We also take a picture, you know. Bye. Have a nice day.
Do you also have a handout?